Assalamualaikum. Now I will explain about example solution process for chapter 1, physical quantities and measurements. For example 1.1, determine a dimension for linear momentum. So we must write the symbol for dimension for each of the physical quantities. So dimension of mass is capital M. Dimension of V is LT to the power of -1. Therefore, dimension for linear momentum is ML T to the power of -1. Next, for example 1.2, determine a dimension for force. So, we must write the symbol for dimension for each of the physical quantities for the formula of force. The dimension for mass is capital M. Dimension of A is LT to the power of -2. Therefore, dimension of force is ML T to the power of -2. Next, for example 1.3, determine whether the following expression S is equals to UT plus half AT squared is dimensionally correct or not. Physical quantities S, U, A, and T represent displacement, initial velocity, acceleration, and the time of an object, respectively. So, dimension on the left-hand side, dimension of displacement is capital L. Dimension of initial velocity, U, is LT to the power of -1. Dimension of time is T to capital letter. Therefore, dimension of UT is capital L. Next, for dimension of half is 1. Dimension of A is LT to the power of -2. Dimension of T to the power of 2 is T capital letter squared. Therefore, dimension of half AT squared is equals to L. Dimension on the left-hand side is equal to dimension on the right-hand side of the expression. Therefore, the equation above is homogeneous or dimensionally correct. For example 1.4, determine whether the following expression V is equal to U minus 2GS is dimensionally correct or not. Physical quantities S, U, V, and G represent displacement, initial velocity, final velocity, and gravitational acceleration, respectively. Dimension on the left-hand side, which is dimension of final velocity, is equals to LT to the power of -1. Dimension on the right-hand side, which is dimension of initial velocity U, is equals to LT to the power of -1. Dimension of 2 is 1. Dimension of G is LT to the power of -2. Dimension of S is L capital letter. Therefore, dimension of 2GS is equals to L squared T to the power of -2. Dimension of V is equals to dimension of U, but is not equal to dimension of 2GS. Therefore, the equation above is not homogeneous or dimensionally incorrect. Next, for example 1.5, a displacement vector has a magnitude of 175 meters and points at an angle of 60 degrees relative to the x-axis in figure 1. Calculate the x and y component of this vector. X component is equals to s cos theta. Magnitude of s is 175, cos with angle 60 degrees, so is equals to 87.5 meters. Y component is equals to S sin theta, which is equals to 175 sin 60 degree, which is equals to 151.55 meters. For example 1.6, a particle B experienced a force of 100 Newton as shown in figure above. Determine the X component and the Y component of the force. First of all, we must find the smallest angle, 30 degree. Then we use that angle to calculate x component and y component. X component for the force is equals to negative because direction to the left. Negative F cos 30, which is equals to negative 100 cos 30, which is equals to negative 86.60 unit Newton, capital N. For the y component, which is equals to F sin 30, which is equals to 100 sin 30, and equals to 50 Newton. Thank you for listening.